The point of this experiment is to try to determine the amount of excess charge on a specially prepared ordinary object. The object in this case is Scotch tape. I will detail my expectations, observations, measurements, and results. I expected that the two U-tapes would repel one another due to each having the same charge. I also expected that the U-tapes would each gain a negative charge. This proved to be incorrect. Lastly, I expected the charged U-tapes would not interact with neutrally charged objects. This also was incorrect. I observed the U-tapes did actually repel each other as expected because they had the same charge. Upon bringing the negatively charged pen to the U-tape, instead of being repelled, the U-tape was attracted. This proves the U-tape was positively charged. I also noted the U-tape was attracted to some neutral objects. It was attracted to me, the table, and even somewhat to the book. I measured the U-tape to be 0.2 meters. The width was measured to be 0.02 meters. Using these measurements, I calculated the mass of the U-tape to be 0.0002 kilograms. In the experiment, when an upper tape was across two books and a lower tape was brought to it, I measured the distance between the two tapes when the upper one started to float at 0.081 meters. Using acceleration due to gravity and the mass of the tape, I calculated that the magnitude of the gravitational force on the floating tape was 2 times 10 to the negative 3 newtons. Since the electric force between the tapes counteracted the force of gravity, the electrical force should also be 2 times 10 to the negative 3 newtons in the opposite direction. To calculate the magnitude of the charge of each of the U-tapes, we were allowed two assumptions: that each of the U-tapes had about the same amount of charge, and that we could treat each tape as though the charge was located in the center. I was then able to use Coulomb's force law for point particles. Plugging in the force of electricity and the distance between the two tapes and solving for the charge, I came up with 3.8 times 10 to the negative 8 coulombs. My glow script code appears to mirror these results. One of the final calculations had to do with the fraction of atoms that gave up electrons. Using an approximation for the length of an atom, I calculated there were 4 times 10 to the 17 atoms on the sticky side of the tape. I also calculated that there would need to be about 2.4 times 10 to the 11 electrons in order for the charge to have a magnitude of 3.8 times 10 to the negative 8 coulombs. This resulted in a ratio of approximately 1 atom out of 1.7 times 10 to the 6 atoms that gave up an electron in order for the U-tape to gain a charge. There were further questions in this lab. If a U-tape is positively charged, how should it interact with a charged plastic pen? Since the charged plastic pen should have a negative charge, these charges are opposites and they should be attracted. If negatively charged, how should it interact? If the tape were negatively charged, these charges would be the same and they should repel each other. How should a neutral U-tape interact with a charged plastic pen? It turns out that a neutral U-tape is also attracted to a charged plastic pen, just not as strongly as a positively charged U-tape. What if electrons had a positive charge and protons had a negative charge? What would change about the observations you made with your tape and other charged objects? As it turns out, the observations wouldn't change at all. If all we're swapping is positive charges for negative charges and vice versa, then we would still have the situation where equal charges would repel and opposing charges would be attracted. Why is it important to handle the charged tapes as low as possible? What happens when the charged tapes come into contact with your hands or other objects? The reason to handle them very little is because when coming into contact with you or other neutral objects, the charge gets distributed to the other object. Finally, I've included a copy of the glow script code I used for the three-dimensional force vectors on the results slide.